Okay, homework number 1. Question 1 says the current in a conductor is 1.5 amps. How many coulombs of charge pass any point in a time interval of 1.5 minutes? So to start this question, we use the equation I equals Q over T. I, which is the current, is given 1.5 amps, and the time is also given 1.5 minutes, 1.5 minutes, which is the time interval. Now to find the charge in coulombs, we use this equation. I equals Q over T. So we're given the current, which is 1.5 amps, equals the unknown, which is the charge, over the time, which is 90 seconds, which is also equal to 1.5 minutes. So once we plug the givens in, we solve for the charge, which is Q, and we multiply 90 seconds on both sides, and when we multiply 90 seconds times the 1.5 amps, we get 135 coulombs. Okay, moving on to question number 2, which says that 4 coulombs of charge pass through the element in the given figure from point A to point B. If the energy absorbed by the element is 160 joules, determine the voltage across the element. So, thinking about this question, we know that the work that's being done is given, which is 160 joules, and also that the charge is 4 coulombs. So that brings me to this equation here, which says the work equals voltage times the charge. So we plug what we're given in to find the unknown, and I got this equation by rearranging the first equation only by dividing the charge on both sides. And so with that being said, I got 160 joules for the work divided by 4 coulombs of charge, which gave me 40 volts. And the reason that it is positive is because the 4 coulombs of charge move from A, which is from A to B, which is from positive to negative. Now, moving down to question number 3, says if the charge in the given box is presented by the plot in the following figure, determine the current I entering the box and plot. So, this is the plot that is given, and this is the equation that I will be using, which is I equals the change of Q, which is the change in charge, over the change in time. And when we're finding the change in anything, we take the final and we subtract the initial from it. So, for the first one, from 0 to 1, the charge difference was negative 0.5 coulombs. because I subtracted 0.5 from 1, which gave me 0.5. Negative 0.5. Right. And the time difference is 1 second, because 1 minus 0 is 1. And so when we plug these two answers into this equation, charge divided by time, we get negative 0.5a, which I marked here. For 1 to 2, there was no charge difference in charge from 1 to 2. So plugging everything in, for current I got 0 amps, which is indicated here on the x-axis of 0. And then from 2 to 3, there's a decrease from 0.5 to negative 1.5. And when I plug the charges into this equation, I got negative 2. And for the time, 3 minus 2 is 1. And plug these two in this equation, I got negative 2, which is indicated here. So next is this line here, 3 to 5, was an increase in charge, which when I plug the charges into here, from negative 1.5 to positive 0.5, so I take 0.5 minus negative 1.5, which it becomes positive, and we end up adding to get 2, and the time difference, 5 minus 3 is 2. Plug it into this equation and we get 1. From 5 to 6, there's a decrease in charge from 0.5 to negative 0.5. So plugging it into the equation, negative 0.5, which is the final charge, to the initial charge, which is positive 0.5. I'm sorry. No, that's right. That's why it gives us negative 1. And 6 minus 5 is 1. Plug it into here, and we still have negative 1. From 6 seconds to 7 seconds, there's, again, no change. So it stays at 0, which is shown here. 0, 1, and current becomes 0. Current is 0. And from 7 to 9, there's an increase. So the initial is negative 0.5 and the final is 0. So 0 minus a negative 0.5 gives us a positive 0.5. 9 minus 7 is 2. Plug it into this equation and we get 0.25 amps. And that is indicated right here in the middle of 0 and 0.5. And for the last question, question 4 says, find the power that is absorbed or supplied by the network elements in figure P 1.3032. So, Figure P1.32a. We have the first element, element 1, which here P1, and P equals IV. Power equals current times the voltage. And we're given one more thing, Ix, which is equal to 2 amps. So for the first element, we indicated this as P1, and since the current is moving in from positive to negative, we have a positive 2 times 8 gives us 16 watts, and the 8 comes from the voltage. Going along this line, we get to 2Ix, which we indicate as P2Ix, and we have again positive current moving from positive to negative, and 2Ix is 2 times Ix, which is 2A, and that gives us 4. And 4 times 2 is 8. Next we have P12V, and the current is moving along this branch from negative to positive, which then gives us negative current times 12 volts gives us negative 24 watts. So for the second figure, we're going to start with this element that is labeled 1, and the current for this one is moving positive to negative, so we have a positive 2A, 2 amps times 20 volts, which gives us 40 watts. And for P2, current again is moving from positive to negative, which gives us positive 2 amps times 12 volts, which is 24 watts. And for P4Ix, current is moving in negative to positive, which gives us negative 2 amps. And then 4Ix is 4 times Ix, which is 2 amps, which will give us 8. And we multiply that by the negative 2, the current that is going into there, going through there, and we get negative 16. And for the last element, P, 24 volts, current is moving in here as well from negative to positive, so we get negative current of 2 amps times 24 volts, which gives us negative 48 watts. And that is my homework explanation.